Hello everyone, I am Prashant Kumar, pursuing BE at Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss about clustering algorithms from subject data mining and data warehouse 21IS643. Now having a look through the table of contents where we are going to discuss about CLA array, Clarence, ROC algorithm, link-based clustering, wave cluster algorithm, and finally conclusion. Introduction. Clustering algorithms in data mining are essential for organizing and understanding large datasets by grouping similar data points. They aim to discover underlying patterns and structure without prior knowledge of data labels. Common algorithms include k-means hierarchical clustering and dbScan, each situated to different data types and shapes. Clustering aids in exploratory data analysis, anomaly detection, and customer segmentation in diverse fields like biology, marketing, and finance. The choice of algorithm and parameters significantly impacts clustering effectiveness, requiring careful consideration. Advances in clustering continue to improve scalability, efficiency, and applicability in handling complex data sets in modern data-driven environments. Clara, Clustering Large Applications, 1990. Kaufman and Rosso, built-in statistical analysis packages such as S+. It draws multiple samples of the dataset, applies PAM on each sample, and gives the best clustering as the output. Strength, deals with larger datasets than PAM. Weakness, efficiency depends on sample size. A good clustering based on samples will not necessarily represent a good clustering of the whole dataset if the sample is biased. Clarence, randomized Clara, 1994, a clustering algorithm based on randomized search. NG and HN in 1994 draws a sample of neighbors dynamically. The clustering process can be presented as such a graph where every node is a potential solution, that is a set of k midpoints. If the local optimum is found, it starts with new randomly selected node in a search for new local optimum. Advantages: more efficient and scalable than both PAM and Sclara. Further improvement: focusing techniques and spatial access structures. ROC clustering categorical data. ROC, robust clustering using links. S. Goa, R. Rastogi, and K. Shim. Major ideas: use links to measure similarity and proximity, not distance based. Algorithm: sampling based clustering. Draw random sample, cluster with links, label data in disk. Experiments: congressional voting, mushroom data. ROC algorithm. Method: compute similarity matrix, use link similarity. Run agglomerative hierarchical clustering. When the dataset is big, we have to get sample of instructions and cluster the sample. Problems faced: guarantee cluster interconnectivity. Any two transactions in a cluster are very well connected. It ignores information about closeness of two clusters. Two separate clusters may still be quite connected. Computing similarity with aggregation. To compute similarity of Na and Nb, we have to find all pairs of sibling nodes Ni and Nj so that Na will be linked with Ni and Nb with Nj. Then calculate similarity and weight between Na and Nb with respect to Ni and Nj. Then the calculated weight average similarity between Na and Nb with respect to all such pairs. Link-based clustering. Calculate similarities based on links. The similarity between two objects x and y is defined as the average similarity between objects linked with x and those with y. J and Vidom in 2002 SimRank. Two objects are similar if they are linked with same or similar objects. Issue: expensive to compute. For a dataset of n objects and m links, it takes O of n square space and O of m square time to compute all the similarities. Distribution of similarity. Power law distribution exists in similarities. 56% of similarity entries are in 0.005, 0.015. 1.4% of similarity entries are larger than 0.1. Can we design a data structure that stores the significant similarities and compresses insignificant ones? Linkless, efficient clustering via heterogeneous semantic links method initialize a sim tree for objects of each type. Repeat until stable. For each sim tree, update the similarities between its nodes using similarities in other sim trees. Similarity between two nodes x and y is the average similarity between objects linked with them. Adjust the structure of each sim tree. Assign each node to parent node that is most similar to. For details, X, in, J, and PSU, linkless efficient clustering. Initialization of sim trees. Initializing a sim tree repeatedly find groups of tightly related nodes which are merged into higher level node. Tightness of group of nodes. For a group of nodes n1 to nk, this tightness is defined as the number of leaf nodes in other sim trees that are connected to all of n1 to nk. Wave cluster, a multi-resolution clustering approach which applies wavelet transform to the feature space, both grid-based and density-based. Wavelet transformation, a signal processing technique that decomposes a signal into different frequency subband. Data are transformed to preserve relative distance between objects at different levels of resolution, allows natural clusters to become more distinguishable. Wave cluster algorithm. How to apply wavelet transform so as to find clusters. Summarizes the data by imposing a multidimensional grid structure onto a data space. These multidimensional spatial data objects are represented in a n-dimensional feature space. Then apply wavelet transform on feature space so as to find the dense regions in the feature space. Apply wavelet transform multiple times which result in cluster at different scales from fine to coarse. Major features: complexity 0 of n, detect arbitrary shaped clusters at different scales, not sensitive to noise, not sensitive to input order, only applicable to low dimensional data. Conclusion: clustering algorithms in data mining are powerful tools for discovering inherent structures in data. By grouping similar data points together, they enable pattern recognition, anomaly detection, and data segmentation. However, the effectiveness of clustering depends heavily on the choice of algorithm and parameters, as well as the nature of the data itself. Evaluating cluster validity is crucial to ensure meaningful results. Overall, clustering algorithms enhance understanding of data relationships, facilitate decision-making process, and support various applications in fields such as marketing, biology, and finance. Continued research focuses on improving algorithm robustness and scalability to handle increasingly large and complex datasets. Thank you.